Okay, so in this talk I will show you our work about establishing national cyber situational awareness through incident information clustering. So as Cyril already mentioned, it's important to have some security operations centers that need to collect cyber incident information in order to then define some mitigation strategies. And so this work is again in the context of the same European project I told you about before, and the important thing to stress here is this hierarchical structure. We have this layered protection of critical infrastructure. So we have this operation and organization security operations center, then we have a national one and a European one. So we're focusing in this work on the National Security Operations Center, and we plan to support the operators working there in incident handling. So as the critical infrastructures are getting more and more complex, also the cyber threats are becoming more sophisticated, and for this reason classical, local, and signature-based detection approaches are not effective anymore, because the attacks are actually carried out on in a distributed way. So we need cooperation for tackling this problem, and for that we need sharing of incident information. So that's the main reason for the establishment of these national cybersecurity centers. And as Cyril already mentioned before, one of the challenges here is to handle big amount of data, huge amount of data. And single or multiple operators, human operators, cannot handle all this information by hand, but definitely they would need some automatic system to support them. So one of the possibility is to support them. One option could be to support them understanding what's going on with the different reported incidents by clustering them. So the system that we propose is composed by the following modules. We have some incident report module, then we cluster the reported incidents, trying to group them and classify them. Then we generate some reports and some statistics about the different clusters and the overall data set, and we support the operator by providing some visualization interface. So first of all, we need to define an incident, and there are different standards that tell us how to describe an incident, like STIX or Cyber iOS, but in this case we're just defining an illustrative schema ourselves, so that it's just for making it simpler to test the clustering algorithm. So we define, starting from CVE database, common vulnerability and enumeration database, we generate some incidents that are described with the following 13 facts. And between these 13 facts, we can see there is like the actor, the company reporting the incident, the damage in euro, so the financial loss caused by the incident, time until discovery, time until report, and so on. So then we select between these 13 facts, 3 of them that we could map on 3 different axes, and we choose some of them that need to be numerical properties. And in this case, we selected the time until discovery in seconds, the damage and the financial loss in euro, and the time until report, also in seconds. So after we have selected these properties for all the incidents, we try to run this clustering model. We use so first of all, we need to define how to measure how different are two incidents, and the distance metric in this case is the Euclidean distance. So basically in this three-axis, the farther 2 points are, the more different are the incidents that they describe. Then we build the cluster tree using hierarchical cluster analysis. So we start assigning each cluster to each entry of each incident correspond to a cluster, and then we merge them going from the bottom to the top of this figure, ending up with a single cluster. So once we have built this tree using this complete linkage method, then we can cut the tree according to this this rule written here, which tells us the optimal number of clusters. So we go now from the top to the bottom of this tree, and we stop once this condition is respected. So basically, it says that when the incidents belonging to the same cluster are different enough, we have to split into different clusters. Okay, some details about the system implementation. We have used an existing framework for it's a data backend and for browsing through the different incidents. It's called Mantis, Model-Based Analysis of Threat Intelligence Sources, and this a framework developed by Siemens, and it's open source. We used this because we found it very friendly to use and easy to extend as well. Since it's based on Django, it was really straightforward to extend its functionalities by writing some Python code. And as you can see from this screenshot, you have all the list of all the incidents. You can click on them, read all the information about them, filter, search according to certain criteria, and so on. So, so Mantis allows us to import different incidents, and there are importers already available. You can import incidents described in sticks or OpenIOC. And but in this case, since we defined our own schema, we had to also write our own importer for acquiring all the incidents that we define. So once we have the different incidents imported in this framework, we can filter through them, and then we wrote also this feature for clustering within this Mantis framework. So that's basically a screenshot you have. You can first filter according to different properties, then you can choose according to which of the facts you want to cluster. It can be 1D, 2D, or 3D clustering, and then we can also select which statistics related to the clusters we want to display after the clusters are calculated. That's what we get after clustering some incidents. And as I said before, we have 3 dimensions, each describing a property of the incident. And once we get the clusters, we identify each cluster with a different color. And by so the size of these dots you can see in this graph also show another parameter, which is the damage score. It was one of the 13 facts that were mentioned before. So when we have a small dot, this means the damage score assigned to this incident was low, and when the dot is bigger, larger, then the damage score is high. You can see that we have a kind of straightforward trend. So the bigger the damage score, the higher is the time to discovery, and the higher is the time to report, and the higher is the financial loss. Of course, we also have outliers, but that's synthetic data, and it would be really interesting to have some real data to assess our system. So after generating the clusters, we have also the statistics related to them, and we have like the average of the cluster diameters, we have median, we have statistics that are properties of the whole data set, and also cluster by cluster.